Welcome to myprojectbazaar.com. Here we are going to discuss about on the performance of spatial modulation optimal constellation breakdown. Modulation. It is the process of varying the characteristics of message signal in accordance with the carrier signal. Several modulation techniques are available for transmission purposes. In this paper, the spatial modulation is discussed. Spatial modulation, it is a new transmission technique for multi-antenna systems. The transmitted antennas are used to modulate the signal which corresponds to our message bits. The symbol error rate performance of spatial modulation investigated in this paper. And also the spatial modulations are implemented in two domains, that is antenna domain, signal domain. These are combined together to achieve the transmission rate. The receiver constellation performance of this modulation also analyzed, and also the optimal constellation breakdown between the signal domain and antenna domain are discussed. The symbol error rate performance of bit-oriented message signal is also analyzed in this paper. The symbol error rate is at any transmission rate the optimal dimension in which the symbol error rate is minimized. The energy efficiency and capacity of the transmission system also described using energy efficiency optimization algorithm. Using this algorithm, the energy efficiency is calculated and the capacity of the transmission for the number of transmitter and receiver variations also carried out using this topology. Finally, the capacity evaluation, energy efficiency calculation, the receiver constellation performance also discussed in separate windows. Here is the system architecture of our proposed work. It consists of four major blocks. The first block OFDM, second block K-best algorithm, third block energy efficiency optimization algorithm, and finally the performance analysis block. OFDM. The architecture of OFDM consists of several steps, that is the binary random sequences are given as an input and the suitable modulation technique is to be performed on the binary data sequence, and the pilot symbol insertion to the modulated symbols are carried out. Then fast Fourier transform are also taken place for the message signal. The guard insertion of the suitable pilot symbols are achieved using the guard insertion block. Then the channel transmission takes place. The channel utilized for the transmission is adaptive white Gaussian noise channel is used. From this channel the symbols are received. The guard removal process takes place and the inverse Fourier transform also applied to the received symbol without guard removal. Finally, the pilot reconstruction also performed. The demodulation of suitable modulation technique performed in the sender side is also carried out to validate the output data. This is OFDM architecture. And K-best algorithm. In a K-best algorithm, the suitable number of minimized path metric is calculated, that is root node, and path metric for the individual node, the ith level, which level is to be written for the purpose, that they are also estimated using K-best algorithm. The path metric calculation provides the breadth first tree search algorithm, which select it as source node, and from the source node identify the path of the individual nodes. Finally, the minimized path is obtained here. And energy efficiency optimization algorithm. Using this algorithm, the energy efficiency and capacity are calculated. The channel optimization problem also estimated. The closed form solution of energy efficiency optimization is derived for OFDM systems. The proposed method iteratively pilot power and efficiency capacity are also evaluated using this block. Performance analysis. Using the performance analysis, the symbol error rate performance and the efficiency and capacity are also estimated here. Next, we are going to discuss about the running procedure of our proposed work. The running procedure consists of 5 functions. One is major function and 4 subfunctions. The main function consists of the declaration parameter for the subfunction calculation, the channel coefficient initialization, transmitter receiver initialization, signal to noise ratio initialization, that are all declared in this main function. So our main function splitted up into 4 processes. The first process is using simple k-means algorithm. We can estimate the probability path, that is minimized path metric is evaluated. From this path, the autocorrelated samples are estimated. That is the second step, which is performed by C0 calculation. After the performance of the C0 calculation and simple k-means algorithm, the minimum mean square error calculation also carried out. Finally, the symbol error rate probability is estimated. The energy efficiency and capacity are also estimated here. The initialization parameters, channel coefficient, declaration, they are all displayed using in the main function. The declaration parameters for our calculation is the number of transmitter and receiver set it as 2 and the modulation scheme selected as 16, and the signal to noise ratio varied for 0 to 30. The iterations for the simulations value is 100. The channel coefficient parameter is randomly generated real and complex sequences. After that, the autocorrelated estimation of samples are also estimated. The mapping of OFDM symbols to the message signals are also carried out. Using this mapping function, the receiver constellation performance estimated. The modulation technique, QAM modulation technique, is applied to the symbols, and 16 QAM modulation technique evaluates the receiver constellation performance. Finally, the symbol error rate performance for theory and simulation are also calculated after the channel coefficient initialization. The channel selected as AWGN, the noise addition to the channel, also estimated here. Now I run the main program. The running procedure shows the 4 number of plots: receiver constellation plot, energy efficiency capacity plot, symbol error rate plot. The first plot, it shows the QAM modulation plot for real and imaginary data symbols at receiver and transmitter. The constellation here is to be optimized to the transmitter values. And this is the symbol error calculation for theory and simulation. The 16 QAM modulation technique is applied for the various number of signal to noise ratio values. We can calculate the symbol error rate probability and it is to be plotted. The efficiency of the system for various average power constraints are also displayed here for a various number of transmitter and receiver. The transmitter and receiver varied 1, 2, 3, 4 and energy efficiency calculated for each number of transmitter and receiver. Then it is to be displayed in this plot. The variations that has to be, it's constantly modulated here. And the capacity. This capacity graph shows the average power constraints values. This effective capacity of the system is to be modeled as constant parameter for a various number of transmitters and receivers. Using this analysis, we can estimate the symbol error calculation. Efficiency capacity of the system is analyzed using spatial modulation technique. Thank you.